Welcome to the Deep Dive, where we take complex military doctrine and, well, we really try to dive beneath the surface.
We do.
We want to transform that procedural knowledge into, real strategic insight.
And if you really want to understand how modern joint forces fight, you have to get into this world. The highly specialized world of joint targeting and close air support.
It's a world that's just defined by incredible pressure, isn't it?
Oh, extreme pressure. I mean, we're talking about the mechanisms that allow a ground force commander who might be totally focused on what's happening 300 meters in front of him.
Right, the immediate fight.
Immediate fight.
Yeah.
And it allows him to seamlessly integrate the just devastating power of an entire air component that's operating maybe hundreds of miles away.
And the one concept that really binds all of this together, the whole reason these structures even exist, is something called commander's visualization. It's not just, having a map on the wall. It's about achieving that fundamental, almost instantaneous and shared understanding of the battlefield.
And that shared part is key.
It's everything. It's what you need to direct truly integrated operations. You just can't get speed and accuracy in joint fires unless the commander has this crystal clear picture that everyone is looking at.
Yeah.
And that picture is built piece by piece through these rigorous, standardized procedures.
Exactly. And to guide our deep dive today, we're pulling from two really essential publications that govern this world. The first is Army Techniques Publication 309.13. It's titled The Battlefield Coordination Detachment, and it's dated July 2015.
Okay.
And the second is Joint Publication 309.3 called Close Air Support, which is more recent, from June 2021.
So our mission for you, our listener, is, well, it's pretty ambitious today.
Yeah, a bit.
We want you to walk away with a complete picture of the liaison roles, the technical procedures, the life and death planning factors, basically the sheer volume of coordination that's required to make this work. We're going to unpack how a ground commander's plan gets translated into a language the air component can actually execute.
So let's start with the one organization whose entire purpose is to bridge that massive gap.
The Battlefield Coordination Detachment.
When you look at the structure of joint warfare, the Battlefield Coordination Detachment is. It's the absolute linchpin.
So Army Techniques Publication 309.13, that's our source here, it says this detachment is the senior Army liaison element.
That's right. But the crucial part, and this is what's so interesting, is that it's not located with the Army commander. It's embedded inside the Air Operations Center.
With the Air Force.
With the Air Force. And its primary job is facilitation. It's making sure that selected operational functions can flow smoothly between the Army Forces commander on the ground and the Air Component commander running the air war.
I found that specific alignment just fascinating because it really clarifies the mission of the Battlefield Coordination Detachment, doesn't it?
It does.
It exists solely to support the Army Forces commander's maneuver units. That is its loyalty. That's its only focus, even though it's living and working inside the Air Operations Center.
Exactly. And to do that, it has to interface directly with every single division inside that Air Operations Center. We're talking intelligence, plans, strategy, all of them.
All to make sure the ground commander's priorities aren't just, heard, but are accurately, and I think the term you used was aggressively represented.
That phrase, aggressively represented, is so key. The role is so much more than just like a mail service passing information back and forth. It is advocacy.
Right.
The Battlefield Coordination Detachment has to ensure there's this continuous mutual awareness. I mean, think about it. You're navigating two totally different perspectives.
How so?
You've got the Army's view, which is maneuver-centric,
Yeah.
usually focused on terrain, very short-term, tactical. And you're trying to match that with the Air Force's view, which is theater-wide, phase-driven, and looking at a much longer-term campaign.
So the Battlefield Coordination Detachment becomes a translator.
The essential translator. It takes Army language, things like critical terrain and decisive points, and translates it into air power terms like strike allocation and target effects.
Right. So what are they actually doing day to day? What are the, the practical tasks that make this happen?
Oh, it's an exhaustive list.
Yeah.
I mean, number one, they are articulating the Army Forces commander's intent. That's the mission, the priorities, the whole scheme of maneuver. They're briefing that directly to the Air Component commander's staff.
Okay, that makes sense.
Number two, they process every single request for tactical air support.
Everyone.
Everyone. Close air support, air interdiction, request for information collection, joint suppression of enemy air defense, electronic warfare. It all goes through them.
So they really are the single portal for every ground-to-air request.
Precisely. But there's more. They are also the primary coordinator for the ground forces requirements for airspace coordinating measures and fire support coordination measures. We'll get into those later, but they are incredibly important.
And I imagine they have to have a say in the daily air plan.
Oh, that's maybe the most critical task. They review the Daily Master Air Attack Plan. This is the blueprint for the entire day of air operations. And the Battlefield Coordination Detachment has to submit critical changes based on what's happening on the ground, which can change minute by minute.
So if a ground commander suddenly shifts the main attack by, say, 12 hours,
The Battlefield Coordination Detachment is the one in the Air Operations Center negotiating those changes to the air tasking order to make sure air power is there to support that shift.
and this brings us right back to commander's visualization.
Absolutely.
The source material, it really emphasizes that the whole mission hinges on the ability of the Battlefield Coordination Detachment to handle, and I'm quoting here, mass volumes of information.
It's fire hose of data. They take the results of the final air tasking order, the who, what, where, and when of every single air mission for the day, and they have to immediately push that complex information back down to the Army Forces staff.
So it's a two-way street.
A continuous two-way flow. And that flow of analyzed, synthesized data is what maintains that shared situational awareness across domains. It makes sure the maneuver commander's plan isn't being, accidentally undermined by an air plan they don't fully understand.
So let's look at the structure. Army Techniques Publication 309.13 says it's organized to mirror the Air Operations Center.
It is, and that's deliberate. You have a headquarters element and then 6 core functional sections plus 2 specialized detachments.
6 sections.
Operations, plans, intelligence, air defense, airlift, and airspace management.
That is a lot of expertise crammed into one liaison element. Can we focus on just a couple of those? For instance, the plans and intelligence sections. They must face some pretty unique challenges being embedded in there.
They absolutely do. Take the Battlefield Coordination Detachment Plans section. They are basically intertwined with the Air Operations Center's Plans Division and Strategy Division.
So they're looking at the long game.
The long game. Their job is to make sure the Army's long-term targeting needs, especially for deep fires like the Army Tactical Missile System or the Guided Multiple Launch Rocket System, are integrated into the air component's targeting cycle days, sometimes weeks in advance.
So they're making sure that when the Army needs a strategic strike in the future, the airspace is already clear and the target has been jointly readied.
That's the goal. They're the long-range strategic synchronizer.
Okay, so what about the intelligence section?
The BACD intelligence section is, well, it's critical. They're the ones bridging the intelligence gap. They link directly with the Air Operations Center's Intelligence, Surveillance, and Reconnaissance Division.
So they're injecting ground intel into the air picture.
Exactly. They take the Army's super detailed, near real-time ground intelligence, like the enemy order of battle, specific troop movements, local threats, and they push it into the overall air component intelligence picture.
And they pull intel back down too, I assume.
Yep. They pull that high-altitude, theater-wide intelligence, like enemy air defenses and campaign-level target analysis, and they feed it right back to the ground staff. That structured relationship is what makes this whole thing predictable, even when the fight on the ground is just utter chaos.
And this framework, it has to be flexible. We're talking joint operations, not just Army and Air Force.
Correct. The Battlefield Coordination Detachment has to be ready to integrate with any service. A great example is an amphibious operation. They might need to plug into the Navy Tactical Air Control Center or the Marine Corps Tactical Air Command Center.
And in those cases, they'd send a smaller team.
They often deploy a tailored element, what they call a Battlefield Coordination Detachment minus. It's just enough people to make sure the land commander's links are maintained, especially during that chaotic transition from sea-based to land-based operations. It ensures a seamless handoff of targeting and airspace control.
So the big takeaway here is that the Battlefield Coordination Detachment is the ground commander's operational voice. It's their dedicated advocate, making sure air power is treated as an integral part of the plan, not just some external asset you call when you're in trouble.
And without it, that idea of commander's visualization across domains, it just wouldn't be possible.
Okay, so that sets the strategic stage. Let's move down to the tactical level, the core of the fight.
Right. Now we're transitioning from that high-level liaison role right down to the pointy end of the spear. And Joint Publication 309.3 gives us the definition we need for close air support.
Which is?
It's air action that is planned and executed to support ground tactical units, and the focus is on timely and accurate fires in close proximity to the enemy.
And it's that close proximity, often measured in just meters, that makes this so dangerous and so incredibly detail-oriented.
The coordination required is just staggering. You're talking about the joint terminal attack controller on the ground, maybe a forward air controller in an aircraft overhead, and the ground forces tactical operations centers. They all have to be in perfect sync.
So what are the absolute non-negotiable planning factors that have to be sorted out early on?
Well, it starts with the basics, which are anything but basic. First is communications planning. It has to be reliable, it has to be redundant, it has to be secure. We're talking multiple radio nets and digital links running at the same time.
Because if the link fails mid-attack...
Tragedy is almost guaranteed. Second, you have to have meticulous airspace, deconfliction, and coordination. You got fast-moving jets mixing with, highly localized artillery and mortar fire.
And third?
Third, and maybe the most complex piece, is the synchronization of that close air support with the ground maneuver and other fire support, like field artillery or naval surface fire support. If the ground unit advances too fast, or if artillery fires into the wrong air corridor, you have a major fratricide incident waiting to happen.
That immediately brings up the fundamental question of risk. And the doctrine is very, very clear on who owns that risk, isn't it?
It is absolutely crystal clear, and this is a crucial point. The authority and the responsibility for ordnance expenditure rests entirely with the supported commander.
The ground commander.
The ground commander. He or she is the one who owns, assesses, and ultimately accepts the risk in that close fight. The aircrew delivers the weapons, sure, but the ground commander makes the final decision to accept all the consequences.
And the pinnacle of that risk, the one that always gets the headlines, is the danger close calculation. What does that mean exactly?
So danger close is a formal designation. It means the ordnance is going to land inside the 0.1% probability of incapacitation distance.
0.1%.
Right. A 1 in 1,000 statistical chance of causing incapacitation to friendly troops from the blast or fragmentation. And because that risk is quantified, the doctrine demands the supported commander explicitly accept it.
How do they do that?
They signal their acceptance formally by passing their initials to the attacking aircraft through the joint terminal attack controller or the forward air controller, airborne. It is a documented, irreversible step that carries enormous weight.
That acceptance, passing your initials? That sounds like immense pressure, especially when your troops are pinned down.
It is. The doctrine focuses less on the emotional impact and more on the procedural diligence. It assumes the supported commander, being right there, has the best context to weigh that 0.1% statistical risk against the 100% existential risk of their unit being overrun.
So the procedure forces a deliberate pause.
It forces a pause and an affirmative documented choice. It's critical because the moment that aircraft is cleared to fire danger close, the assumption of all that risk shifts completely to the supported commander.
Okay, let's move beyond risk to friendlies and talk about collateral damage. Joint Publication 319.3 says minimizing this is a continuous process. What's the #1 cause of it?
The primary cause of collateral damage is a failure in positive target identification.
Hitting the wrong thing.
It's that simple. If you hit the wrong target, you failed. No amount of precision weaponry can fix a bad identification. And this really highlights why the role of the Joint Terminal Attack Controller is so vital. They're the final authority on positive target identification for that specific engagement.
And that leads to the very rigorous process of collateral damage estimation.
And richly, a formal collateral damage estimation can only be done by a certified or qualified analyst. And that estimate then has to be approved by the appropriate commander based on the current rules of engagement.
It's a mandatory standardized process.
It is. And it's used to predict unintended damage to civilians, infrastructure, protected sites, things like that. But, and this is interesting, the methodology itself doesn't account for things like a weapon malfunctioning or unknown delivery errors or secondary explosions.
So it's a mitigation tool, not a guarantee.
It's a procedural mitigation of known risks. It's not a blanket guarantee against every possible bad outcome.
Let's pivot to the technical precision itself. Target location error, or TLE. The doctrine says coordinates have to be accurate enough to work, but you shouldn't delay a strike just to get more precision. That's the classic trade-off, isn't it?
It's the ultimate operational dilemma.
Yeah.
Is a Category 3 coordinate, which is good but not perfect, delivered in 30 seconds better than a perfect Category 1 coordinate that takes 3 minutes to generate.
And in those 3 minutes, the target is gone.
The enemy vehicle is already flanking your position. So the doctrine basically tells commanders, don't let the pursuit of perfection become the enemy of good enough. Get the job done when it matters.
But when perfection is required, that's when we get to target coordinate mensuration.
Yes, target coordinate mensuration is the precise measurement process. You're trying to determine the absolute location of a feature latitude, longitude, and elevation. It's a technical art form, really.
Yeah.
And the people who do it have to be certified to ensure the data is of the absolute highest quality.
And the output of that is categorized by the target location error system.
Right. TLE is broken into 6 categories. Category 1 is the best, most accurate, often coming from those certified mensuration analysts. Category 6 is the worst, maybe just a rough guess.
And the required accuracy depends on the situation.
Completely. In a dense urban fight, with friendlies next door to the target, you might mandate a Category 1 or 2. But in a conventional battle across open desert, a slightly lower category might be perfectly adequate to get the job done.
Okay, so the target is identified, it's assessed, it's located. Now it has to be formally requested. And that's done with the Joint Tactical Airstrike Request, the DD Form 1972.
And there are 2 main types of requests. We distinguish between pre-planned and immediate.
Pre-planned is pretty self-explanatory.
Right, it's foreseen. For example, preparatory fires ahead of a big attack. Those are submitted days in advance, and they're integrated right into the air tasking order cycle.
And immediate requests are the emergency calls.
Exactly. They arise dynamically, outside that normal planning cycle. This is usually for troops in contact. It's the classic, we need help right now call. And that distinction is vital for speed.
How so?
Those immediate requests, especially for troops in contact, they get to bypass a lot of the high-level coordination. They can be sent directly from the Tactical Air Control Party on the ground to the Air Support Operations Center, or Direct Air Support Center, using the Joint Air Request Network. The whole procedure is designed for speed when lives are on the line.
So we've set the stage on just how high the risks are, integrating fast jets with artillery and ground troops. It just can't happen safely without, well, a complex web of boundaries.
And this is where we get into airspace coordinating measures and fire support coordination measures. These are the geometric tools, the lines on the map, that are essential to speed up attacks while also safeguarding friendly forces.
It helps to group them, I think. You have the permissive measures, which sort of clear the way for an attack.
And then you have the restrictive measures, which are designed to safeguard forces and prevent bad things from happening.
Okay, let's start with the big 4 permissive measures. First up, the coordinating fire line.
The coordinating fire line is essentially a line on the map. Beyond that line, conventional surface-to-surface fires, so artillery and mortars, can be delivered without any additional coordination with the headquarters that established it.
So it speeds things up for the artillery guys.
It does. But, and this is an important but, it only covers surface fires. It does not eliminate the requirement to coordinate the airspace above it.
Okay. Next is the fire support coordination line. This one has a slightly different rule.
It does. If you're firing short of the fire support coordination line, you have to coordinate with the establishing commander. If you're firing beyond it, you only have to coordinate with affected commanders. It's a subtle distinction that basically pushes long-range fires beyond the immediate fight without cluttering up the tactical radio nets.
The next one, the free fire area, sounds like the most aggressive.
It is exactly what it sounds like. It's a designated area where any weapon system can fire without additional coordination with the establishing headquarters. It's often used in deep areas where you expect lots of enemy activity and very few, if any, friendlies.
But it's not a free-for-all.
No, absolutely not. The doctrine is clear.
Yeah.
You still have to comply with rules and engagement. You still need positive target identification. You still have to do your collateral damage estimation. You can shoot, but you still have to shoot the right thing.
And finally, the kill box. This is a 3-dimensional area that allows lethal attack without further coordination and, critically, without terminal attack control.
It's inherently permissive. It's designed to let air crews hunt for targets of opportunity without having to check in with the controller for every single pass.
But there's a big caveat, isn't there?
A vital one. The publication makes it clear. If you need close air support near ground forces inside an active kill box, the control element is supposed to change the status of that box to cold box.
Which means stop all uncoordinated attacks.
Exactly. It mandates careful integration, acknowledging that you just can't have uncoordinated attacks happening anywhere near your troops.
Okay, now for the other side, the restrictive measures, the safety nets. First, the restrictive fire line.
This is a line established between two converging friendly forces. Maybe two units are advancing to link up. The RFL prohibits any joint fires, or their effects, from crossing that line without coordination. It's a key tool to prevent friendly fire when your own forces are moving towards each other.
And the most restrictive of all is the no-fire area.
The no-fire area means exactly what it says. No fires or effects of fires are allowed in this area, period. It's usually for things like hospitals, religious sites, or areas with a lot of civilians.
Are there any exceptions?
Only two. First, if the headquarters that established it temporarily approves the fires, and second, if an enemy force inside the no-fire area engages a friendly force. In that case, the engaged commander can respond with the minimal force needed for immediate self-protection.
The primary tool used specifically to separate air and surface traffic is the airspace coordination area. This seems like the one we hear about most often.
It's the workhorse of deconfliction, for sure. It's a three-dimensional block of airspace over the target area where friendly aircraft are considered reasonably safe from friendly surface fires.
And these can be planned in advance or made up on the fly?
Correct. They can be formal, which means they're planned out and published in the theater-wide airspace control order. Or they can be informal, which are more expedient, temporary measures that a commander on the ground establishes for a specific short-term mission.
And inside that airspace coordination area, how do you actually keep the planes and the artillery shells apart?
You use a combination of methods. You can separate them laterally by distance using grid lines or terrain features. You can separate by altitude, aircraft stay above 9,000 feet. You can use time with time on target or time to target windows to make sure the artillery hits 2 minutes before the plane gets there.
But it's usually a combination of those.
Almost always a combination. Lateral separation is especially effective because it ensures the aircraft never even cross the potential flight paths, the gun target lines of the artillery.
This detailed airspace management, it also extends to long-range missiles, which brings us back to the Battlefield Coordination Detachment.
Yes. Army Techniques Publication 309.13 is explicit that the Battlefield Coordination Detachment is the liaison element responsible for coordinating and synchronizing those deep fires, like the Army Tactical Missile System or the Guided Multiple Launch Rocket System, into the Air Operations Center's targeting process.
Why is that coordination so intense for a missile?
Because the flight path isn't just a point A to point B. You have to coordinate restricted operations areas, the launch site itself, potential hazards for the launch crews, and then you have to deconflict the entire flight path of the missile with all the pre-planned air traffic. A ballistic missile launch disrupts a huge chunk of airspace.
So the Battlefield Coordination Detachment is basically filing a flight plan for an artillery rocket.
That's a great way to put it. They're making sure no friendly aircraft flies through its trajectory or is operating near the impact zone during that specific time window. The final safety check is when they notify the Combat Operations Division in the Air Operations Center that the missile is actually in the air, a final warning that the airspace is temporarily active.
Okay, so we've planned the fire, we've secured the airspace. Now, how is the tactical fight actually controlled? The responsibility shifts entirely to the Joint Terminal Attack Controller on the ground or the Forward Air Controller airborne in the sky.
Right. They execute what's called Terminal Attack Control. And Joint Publication 309.3 defines 3 distinct types of control. And the type they choose really dictates the level of risk everyone is accepting.
Let's start with Type 1 control.
Type 1 is the most restrictive. It requires the highest level of trust and, visibility. It mandates that the Joint Terminal Attack Controller, or Forward Air Controller, airborne, have to visually acquire both the attacking aircraft and the specific target for each attack.
Both the plane and the target. Why is that so critical?
Because Type 1 is typically used when the risk to friendlies is the highest, when the target is extremely close. That visual confirmation provides the highest possible confidence that the controller knows exactly where that weapon is going to go. And if the geometry is perfect, the clearance call is simple but profound. Cleared hot.
Okay, so Type 2 control is a step down in restrictiveness. It sounds like it relies more on technology.
It does. Type 2 control is used when the controller can't visually acquire either the aircraft or the target when the weapon is released. Instead, they have to acquire the target using targeting data from another asset, like a sensor on a drone, that has accurate real-time information.
So visual acquisition of the aircraft is not required?
Not required. This is essential for strikes in bad weather, or when the controller just can't get to a position where they can see the target. The clearance call is cleared to engage. The trust is in the data chain, not the eyeball.
And finally, Type 3 control. This one is about efficiency.
Exactly. Type 3 grants clearance for multiple attacks within a single engagement, but it's subject to specific restrictions, like stay west of this road or don't go above this altitude. It's a huge efficiency gain because the controller clears the whole sequence instead of each individual pass. The clearance call is also clear to engage, and the controller's job is to monitor and make sure the aircraft stays within those pre-briefed limits.
And hand in hand with the type of control is the method of attack, which tells the pilot how to find the target. It's either bomb on target or bomb on coordinate.
If the controller briefs bomb on target, the pilot is required to acquire the target or the mark visually. They'll call tally if they see the target itself, contact if they see a mark like smoke, or captured if their sensor locks onto it. In this method, the coordinates don't have to be perfect because the controller is visually talking the pilot's eyes onto the target.
And the opposite of that is bomb on coordinate.
This is the pure precision strike. It requires that the coordinates provided are accurate enough to get the job done without the pilot ever seeing the target.
So they don't need to see it.
They don't. But what they absolutely must do is read back two critical lines from the brief line 4, which is target elevation, and line 6, which is target location from their system display. That readback confirms the aircraft is aiming at the exact spot the controller requested.
And all of this information is passed using the standard 9-line close air support briefing format. This is the structure that makes sure all this time-sensitive, critical info gets passed quickly and completely.
Right. And while the first few lines are about getting the aircraft into the area, lines 4 through 9 are the life and death details.
You just mentioned line 4, target elevation, and line 6, target location. The accuracy requirements for those can vary quite a bit, can't they?
They can, and the controller has to specify that. In a dense urban environment, they might need coordinates derived from certified target coordinate mensuration and will explicitly state target location error category I required. That tells the aircrew exactly the level of precision needed for a safe delivery.
And line 8, that's the ultimate safety line.
Line 8 is the location of friendlies. It's given as a cardinal direction and a distance in meters from the target to the closest friendly position. So, something like southwest 300. This is crucial because it lets the aircrew assess the risk themselves. It's the metric they use for their own internal safety checks before they release a weapon.
And finally, there's the remarks and restrictions section. This is kind of the catch-all for everything else.
It is. This is where the supported commander's danger close initials are passed. It's where you'd specify a mandatory final attack heading to keep the aircraft out of the path of, say, artillery fire. And it's where time on target restrictions are passed. These restrictions are not optional. They dictate the geometry and timing of the whole attack.
And to achieve that positive target identification during the attack, the controller often has to use target marking techniques. Laser designation is probably the most famous.
It's incredibly accurate, but it demands very strict coordination. The controller has to brief the laser acquisition zones, the laser to target line, and the final attack heading to avoid something called backscatter.
What exactly is backscatter? Why is it so dangerous?
Backscatter is when the laser energy bounces off particles in the air dust, haze, whatever, and creates a false light source near the person with the laser. If the aircraft's approach angle is wrong, the weapon seeker might get confused and lock onto the benign backscatter near the friendly position instead of the actual laser spot on the enemy target.
Which is why the geometry has to be perfect.
The geometry is everything.
For night operations, they often use infrared pointers.
They do. It's great because the mark is invisible to the naked eye. The risk, though, is that if the enemy also has night vision, you might be giving away your own position. So to mitigate that, aircrews have to call visual to confirm they see the friendly position and then contact sparkle on each attack, confirming they see the infrared beam on the actual target.
And when all the tech fails, the last resort is the talk-on.
The talk-on is the narrative method. You have to do it logically, usually from big to small. You start with a big, obvious feature like the north end of that tree line, and then you walk the pilot's eyes down to the specific target. The controller has to be really aware of their perspective versus the pilot's perspective from 10,000 feet. They're seeing two different worlds.
We also have to talk about rotary wing close air support. Helicopters are just a different beast than jets.
They are. They offer immediate, persistent fires, and they can fly low using what's called nap of the earth flight. Now, Army attack helicopters usually operate as part of the ground maneuver plan, but they have to be proficient in all the standard close air support procedures when they're supporting other forces.
And they use different control measures, right?
They do. They don't use initial points like fixed-wing jets. They use holding areas and battle positions, which are typically defined using the keyhole template. It's a system based on direction and distance in kilometers from the target, not nautical miles. Their movement is dictated by the likelihood of enemy contact. Traveling if contact is unlikely, traveling overwatch if it's possible, and bounding overwatch if contact is imminent.
All the information we've just detailed, it's just a massive amount to communicate verbally.
It's voluminous. And while voice is still the primary method during the final attack, modern warfare relies very heavily on digitally aided close-air support systems to speed everything up and increase situational awareness.
And the technical backbone for that is the variable message format.
Correct. Variable message format, or VMF, is a standardized message protocol that's usually transmitted over combat net radio. This is what lets you digitally send a perfect 9-line brief or an update to the target location error.
But not all systems speak VMF, and not all platforms use combat net radio. This is where gateways become critical, right?
The gateways are the essential translators. They're hardware and software that translate data between incompatible digital systems. For instance, a gateway can take a VMF message from a ground radio net and broadcast it onto a high-capacity network like Link 16. That single function is what broadens the shared picture to the maximum number of platforms. Without gateways, the digital info stays trapped in its own little stovepipe.
A huge benefit of this is the video downlink, VDL, which gives ground units full-motion video. That must be a game changer for target verification.
It is, but the Doctrine gives a really strong warning about it. Full-motion video feeds should not be used as the single source for target identification. Video can be misleading. You can have sensor lag, atmospheric distortion. The controller has to correlate that video with other data.
And there are specific brevity codes just to manage that video feed.
Yes, very simple ones. Handshake means the ground unit has a good link and is receiving video. Hollow means the link is lost. And if that link goes hollow at a critical moment, the ground unit just lost its eyes on the target.
These digital aids also enable the role of the Joint Fires Observer.
The Joint Fires Observer is an information amplifier. They provide timely and accurate targeting data, basically acting as the eyes and ears for the Joint Terminal Attack Controller. But, and this is key, they do not have terminal attack control authority. They can't say cleared hot.
So what are their main digital actions?
Their main job is sending detailed position reports and observation reports. They use a specific VMF message to send friendly positions and targeting data up to the Joint Terminal Attack Controller, helping that controller build a complete picture and manage multiple air attacks at once.
We should also touch on Special Operations Forces gunship integration, because they play by slightly different rules.
They do. Special Operations Forces gunships are unique because of their incredible onboard sensors and fire control systems. They often do not require a specific type of terminal attack control, a type 1, 2, or 3, unless the ground commander specifically mandates it.
So how does a controller talk to them?
They usually use a very concise call-for-fire format, almost like an artillery request. The key guidance is for the controller to request the desired effects. We need suppressive fire on that tree line, or destroy that vehicle, rather than dictating the specific weapon. You trust the highly trained crew to pick the right tool for the job.
Finally, Army Techniques publication 3-9.13 reminds us that joint fires aren't always about blowing things up. There's a balance between lethal and non-lethal actions.
That's right. The strategic environment is rarely purely offensive. Lethal actions are about speed, surprise, shock. Non-lethal actions are often for stability tasks, using constructive or coercive activities.
And what does non-lethal air power look like?
It could be a huge range of things. It could be dropping leaflets. It could be electronic attacks to degrade enemy command and control. It could even be computer network attacks. One of those high-profile examples, though, is the show of force.
Explain the show of force.
It's a non-lethal application of close air support. An aircraft will do a low, fast pass to demonstrate resolve, to deter hostile action, or to disperse a crowd without dropping any weapons. It's often used when the rules of engagement are very restrictive, or when friendlies are just too close for any ordnance. It's using the presence of air power as a weapon itself.
So what this whole deep dive reveals, I think, is that joint operations aren't just about having powerful weapons. They're about connecting them with this massive, sophisticated network of procedures and checks and balances.
It's all designed to maintain high situational awareness and minimize tragic errors. From the organizational advocacy of the Battlefield Coordination Detachment all the way down to the real-time correlation required by the Joint Terminal Attack Controller on the ground, every single step is about building and maintaining commanders' visualization.
That rigorous process.
Yeah.
Taking an objective, turning it into a joint tactical airstrike request, deconflicting the airspace coordination areas, delivering a perfect 9-line close air support briefing format. It's the architecture that lets all these different forces work together.
It really is. It's a testament to the fact that in modern doctrine, communication is the ultimate precision weapon.
This whole integration model, from the basic liaison organization all the way to digital synchronization, it fundamentally shows that joint operations are a constant race. A race between friendly knowledge accumulation building, that perfect commander's visualization, and the enemy's reaction time.
Indeed. And, that brings up a provocative thought for the road.
Okay.
The models we talked about today, they're all based on human input, human certification, human decision-making about risk. But as we see future advances in autonomous systems that can generate coordinates, pick weapons, and propose flight paths almost instantly, how does that compress the decision timeline? If accuracy and speed become automated, will the most critical planning shift from days or hours down to mere seconds? And what does that mean for maintaining legal and safety standards like collateral damage estimation and getting rules of engagement clearance when the pace of war is being set by machines?
That is a profound question about the future of warfighting and risk itself. Thank you for joining us as we explored the core mechanics of joint targeting and close air support.
We hope you leave here feeling much more well-informed about the complex procedures that govern the modern joint battlefield.
We'll catch you on the next deep dive.